Hello grade 4, I hope you are all well and ready for your natural science lesson today. I hope you're all staying at home, staying safe and staying healthy. So I'm going to take this opportunity, as I always do, just to remind you of our email address, grade4@worksheetcloud.com, should you have any questions or comments about this lesson or any of your other lessons that you've had on WorksheetCloud. And remember, that doesn't necessarily mean it's just for natural science. You can use that email address to speak to your maths and your English teachers as well. So you know me, I love to start a lesson by recapping what we've done in the previous lesson, and I thought we would look once more at reversible and irreversible changes by doing a little quiz together. So I have up here some questions, and let's see if you can answer them for me. Are rusting and burning and cooking examples of reversible or irreversible changes? Now remember, an irreversible change is one that you cannot go backwards with. A chemical reaction has occurred and a new product has been formed. So with rusting and burning and cooking, we can definitely say those are irreversible changes. And I think yesterday I used the example of baking a cake. If I add in my flour and my eggs and my milk and my sugar and I make a lovely cake, I will never be able to get those individual ingredients out again. However, I wouldn't want to, because then you don't have a yummy cake. So with that in mind, you can see if you can answer this question: are melting, freezing and evaporating irreversible or reversible changes? That's right, they are reversible changes because I can go backwards in the water cycle. I can freeze my water to ice, I can melt it to get back a liquid water, and I can boil it to evaporate that water off into water vapor. If I then cool and condense the water, I can get liquid water again. Okay, so those are really relatively easy. Let's see if we can test you now with a true or false. True or false, most reversible changes are physical changes. It is of course true. Physical changes can be reversed back, whereas chemical changes cannot. Now for this part of the quiz, I have on your screen a list of different changes, some physical and therefore reversible, and others that are chemical and therefore irreversible. I'd like you to see if you can pick out of the list the irreversible changes. Now, if you did your activity after yesterday's lesson, this should be relatively easy because I've chosen some of the same ones that were on your activity sheet. So take a couple of seconds to have a little look over. Okay, if you need any more time, I suggest you pause your video. Otherwise, I'm going to go through them now. So the question asks, which are the irreversible changes? Well, frying an egg. Yes, it's irreversible. I will never get a liquid egg back from the fried solid one. Freezing water to make ice. Is it reversible or irreversible? Well, it isn't irreversible because I can melt the ice to get back to water, liquid water that is. Melting chocolate, is it irreversible? No, of course not. Melting chocolate becomes liquid, but then you can put it back at room temperature and it will solidify. It will not retain its same shape unless you have the original mold and can pour the liquid chocolate into the mold. But that doesn't matter. It is still chocolate. The chemical, there's been no chemical change to the, what was the word we used yesterday, grade 4? To the reactant. Mixing vinegar and bicarb of soda. Hopefully you all picked that one out as an irreversible change because I demonstrated it yesterday on camera for you. Now this one's quite tricky sometimes for people, dissolving salt in water. It is not an irreversible change. I can get back the salt and the water separate if I evaporate the water off and then condense the water back into liquid water. Burning wood, reversible or irreversible? Is it irreversible? Yes, similar to the matchstick yesterday. If I burn wood, I am never going to be able to get wood back from the ash and the cinders I create. Making bread into toast. Again, this was one of the examples I gave yesterday. It is definitely irreversible. A chemical reaction has changed in the bread when you have heated it. I will not be able to get back the bread. And then lastly, water turning into steam. And because it's part of the water cycle, you should all be able to tell me that that is not irreversible. It is a physical change, and condensing will then get me back that liquid water from the water vapor. Now, here is a bit of an extension question for those that like to challenge themselves. True or false? Beating an egg changes the consistency of the egg irreversibly, but the chemical composition of the egg has stayed the same. Is that true or is that false? Have a little think. Maybe pause your video if you'd like to. Well done if you said that the statement is true, because in beating the egg, although I have now mixed the yolk with the white, I have not changed the chemical compound of the egg at all. So well done. If you've got the majority of those questions right, then I know that you have solidified, a little bit of a science teacher joke there, your understanding of chemical changes and physical changes and how some are reversible and some are irreversible. So where does that lead us today when we continue to study matter and material? Well, we've looked at what matter is. We've looked at the properties of the states of matter and how those states of matter change from one to another. We've looked at the water cycle, and we have now looked at the fact that some changes are chemical and therefore irreversible, and some are physical and therefore reversible. And that then leads us on today to look at the properties of materials that the states of matter form. So for our lesson objective today, we are going to be learning about different materials' properties and how they are suited for their jobs. There's going to be a lot of vocab that you're going to get from today's lesson. In fact, I haven't actually created a vocabulary list as I usually do at the beginning of each lesson, because that is the whole learning objective of today, is for you to understand the words that we use to describe the properties of materials. Okay, so let's get thinking. I'd like you to take a couple of seconds to have a little look around the room you are currently sitting in, and I want you to think about the materials that you see. Now remember, materials are what items are made of, so saying desk is not a material. What is the desk made of? Sometimes, some people, my desk currently in front of me right now is made of wood. However, you might have a plastic desk or a metal desk sometimes. So what is the material it's made of? Take a couple of seconds, pause the video, and go around the room and see how many different materials you can see. Now, I did that just before I started this lesson in this very room, which, by the way, is my daughter's room. So I'm going to click and I'm going to show you the things that I spotted. I spotted stones. My daughter is loving that. Remember, my daughter's 4. She loves the painting of the stones that you can do. And then in Cape Town, I'm sure you have the same across the country, we hide them when we go on trail walks. And then you pick them up if you are lucky enough to spot one. So stones, there are stones in this room. There's cushions. I have some nice cushions and bean bags for her in the corner. Glass, there's glass in the window frames. Drawers, in the desk I've got drawers, and also on the bookshelves I have some drawers. Pencils, my daughter absolutely adores colouring in, and we go through so many pens and pencils. Carpets, there's a rug on the floor here, not that you can see. Grass. Now, you'd actually laugh, but I'm doing her homeschooling at the moment, and she's been asked to create an autumn picture from things around the garden. So there's actually some leaves in here as well as some grass that she's stuck on her picture. And as I said, the desk, but remember, the material the desk is made of is, in this case, wood. So those are some of the items around the room, all made of different materials. But why are they used? Why are certain materials used for certain jobs? That's the point of our lesson today. So if I go to my next slide, here I have a little diagram I've split in, and I've taken some of the items that I've told you I've seen around this room, and I've decided to split them into materials that are hard, materials that are soft, and materials that are flexible. So my drawers, the drawers are hard. If the drawers were soft and flexible, they wouldn't do a very good job of holding things I put in them. The cushions are soft. You don't want to sit on a cushion that is hard like stone. It'll very, very much hurt your bum. The glass is hard. It is not easy to break. I don't want windows that easily break. Now, I've put the carpet in the middle here, both between soft and flexible, because that is exactly what it is. It is flexible. I can roll it up if I need to and take it out to clean it, but it is also soft and nice to walk on. Obviously, the stone is hard. I've said the grass is flexible because if you took a blade of grass and you bend it and play with it, that's exactly what you get. It is flexible. The desk is hard. I don't particularly want a desk made of a flexible material. It wouldn't be very nice to work on. And the pencils are hard. Now, I know some of you have those rubbery pencils that you can bend, but all in all, we do generally need pencils to be rather hard. Now, at the beginning of the lesson, I told you I wouldn't have a vocabulary list like I usually do at the start of a lesson, because the entire lesson really is one long list of different scientific words that we use to describe the properties of materials. So up on the screen in front of you, on the left-hand side, or your right-hand side, I think, you'll see a list of words: transparent, flexible, strong, elastic, magnetic, a thermal conductor, and a thermal insulator. And opposite those words, you will see some meanings or definitions. Now, they do not match. So transparent does not mean an object that can be stretched and will return to its original shape. But somewhere along this list is the definition of transparent. So I would like you to take the time now to pause this video and see if you can correctly match up the term with its definition. Now, I hope you hit that pause button to take the time to look through the words. If you didn't, now last opportunity to do so. Okay, I'm going to go through the answers. And what I would recommend you do if you are keeping that scientific dictionary is to come back to this point in the video after the lesson is finished and pause it to add these words to your dictionary. Right, so transparent. What does the word transparent mean? Well, it means that an object is see-through. So if the glass in the window frame of this room that I mentioned earlier, I can see through it, therefore the glass is transparent. Flexible. Flexible means that an object will bend. We often talk about the flexibility of a person. My flexibility is incredibly poor, but someone like a gymnast is exceptionally flexible. If you can stand upright this second and bend down and touch your toes, then that's better than I can do. Strong, obviously I'm assuming most of you know the meaning of the word strong. I do apologize if my video is covering that word right now. I can't really see it, but it means that an object won't break easily. Elastic. Elastic means that an object can be stretched and will return to its original shape. So something like an elastic band gives you a good idea as to why it's called an elastic band. Magnetic. Magnetic means that a magnet will be attracted to the object. Again, I do apologize if my video is covering those words slightly. A thermal conductor. A thermal conductor allows heat to pass through it. So if I'm thinking about my cooking, I want to have a saucepan that is a thermal conductor. I want the heat to be allowed to come through the saucepan to boil whatever the water is that I've got in there. The opposite of that is a thermal insulator. That means that an object will not let heat pass through it. The word thermal here means heat. So if you think about thermals, maybe some of you have been lucky enough to go skiing or to a very cold country. You've been asked to wear thermal underwear or thermal clothing. It's to insulate and keep your heat in, but the word thermal itself means heat. Now, if you thought that those were my only words for today, you were wrong. I'm afraid I've got some more to throw in there. So now I have 6 other words: translucent, opaque, durable, electrical conductor, electrical insulator, and waterproof. So once again, I would like to recommend that you take this opportunity to pause the video and have a close look at those words and the definitions that are opposite them and see if you can match them correctly. Right, let's go through them. Translucent sounds very similar to transparent, and the meaning is also similar. A translucent object lets light pass through it. So a good example of this might be a lampshade, whereas glass is transparent and I can see totally through it. Translucent objects allow some light to come through them. So a lampshade diffuses light to make it a nice warm light in a room, but it doesn't let you see right the way through to the light bulb itself. Now, the opposite of transparent, if transparent means see-through, would be opaque, because opaque does not let any light through it, okay? So if you're looking at a wall in your house, the wall is opaque. I can't see through the wall to the room on the other side. Durable. If something is durable, it means it is long-lasting, okay? I don't want to have a garden bench that I have to replace every year because it's not durable and can't stand the weather. Electrical conductor. Well, if a thermal conductor on the previous slide we learnt about is a item that allows heat through it, then an electrical conductor is one that allows electricity to flow through it. Put my tongue in my mouth. And an electrical insulator is one that does not allow electricity to pass through it. So I'm looking down at the floor now and I see the cable that is plugged into my laptop. Inside the cable are the wires. The wires, some are copper, they are electrical conductors. They allow the electricity to flow, but the cable is then covered in some plasticky rubber, and rubber is an electrical insulator. So I don't want to touch raw wires while electricity is going through it and get an electric shock. Waterproof, the last one, means that it will not allow water to through it. Okay, so there's no good in having a rain jacket that is absorbent. There's another word for you. I don't want my clothing for wet weather to absorb water. I want it to allow the water to run off of it. So now we know a whole heap of new terminology. We can use them to describe certain materials. So here I have an image of this bridge. It's made of certain metals. Well, it is strong. It is hard. Other words could be durable. Steel is not going to need to be replaced every year because it's not weathering very well. But can you think of other materials that bridges are made of and why they are made of those materials? Here's a window. A window is made of glass. Very simply, why? Why do I want a window made of glass? Well, because it's transparent. the most important function of a window is to allow natural daylight into a room. I have a window right in front of me here, and it is allowing you to see me currently. Okay, I don't want to have to burn electricity all day long because I don't have a house with windows. Glass is also quite strong, especially the glass that they use to make windows from. I know that they're going to be long lasting, durable, and they are not going to break easily. Now, an item that I'm sure you've all got in your pencil case is a ruler. Well, why is this ruler made of plastic? Well, it is because it's hard, but at the same time flexible. A ruler can be bent ever so slightly and it doesn't shatter as if it was made of glass. Although some industries, such as if you want to study architecture or things like that, they use metal rulers because they don't want them to be that flexible. They need their measurements to be incredibly accurate. How about a catapult? A catapult is made of rubber. Now, hopefully you've never used one on anyone. They're very naughty if you use them on him. But here I've got a picture of a boy and he's got a wooden frame to his catapult. But this here is rubber. It is made of rubber because rubber is elastic. Okay, so I can pull back the catapult, let go of the projectile, and the rubber will spring back into its original shape. How about a compass needle? A compass needle is made of metal because metal is magnetic. Now, can you think of any other materials that are magnetic? Are all metals magnetic? Are all materials magnetic? Well, some materials are magnetic. This means that they will attract a magnet, as we learnt on the original definition slide. So which of these materials below do you think will be magnetic? Will it be the logs of wood, the paper clips, or the telephone? So here I have my magnet. Have a little think. That's right, it will be the paper clips. The paper clips are made of steel, so therefore magnetic. How about a t-shirt? You might be currently wearing a t-shirt and it's made of cotton. Why is it made of cotton? Well, because cotton is soft. It's also we call it a breathable material. It allows air to come through it, which is very important. It's particularly in sportswear. But what other materials could be used to make your clothing? You might even want to take the time to have a little look on the label inside your top, and it will tell you exactly what fabric makes that top. Now in Cape Town at the moment, I'm sure if you're living in Cape Town, you've felt that little bit of a chill in the air in the mornings and the evenings. It's starting to get a bit colder as autumn sets in. So many of you may be lucky enough to have a radiator, or in South Africa, I think you call it a wall heater, made out of metal. Why are they made out of metal? Well, because it's a good thermal conductor. It allows the heat to pass through it. Whereas the opposite side of that, if I have a saucepan in my kitchen and the handle is made of wood, it's because the wood is a good thermal insulator. I want the pan itself to be metal to allow the eggs to fry, but I don't want to fry my hand when I pick up the saucepan. So here is a picture of a classroom. I'd like you to have a little look, pause your video again, and see what materials are being used around this classroom and why. Well, I could go on and describe every single thing in this room, but let's just go over a couple. I see plastic with the plastic chairs. Plastic chairs, especially for children, are often lighter than if you were to have a chair out of metal or wood, easier for children to maneuver around. They're also clean and durable, easy to clean. You can give them a good scrub down. Same with the tabletops made of wood, okay? They are strong, They are durable, but they're also easy to clean. I can see paper on the walls. Obviously, paper is important for the colour and the vibrancy, and they're opaque. I don't want to see through it, compared to the glass of the door here, which is transparent. The carpet on the floor is obviously soft, whereas the tiles here are hard. So there's lots of different things here, even down to the light bulbs in the lights. Those are transparent to allow all the light to come through. I'm sure you have spotted many more different objects than I have. So now let's have a look at something a little closer to home, and this lounge. Now this is not my lounge. I wish it were. It's beautiful. But some of the items that I have seen being used here are the wood for the table, because they are strong, hard and durable. I've seen bamboo in the chairs. Now the bamboo, once it's dried, it's flexible. It means it's been able to be woven into those beautiful chairs. There's a marble surface which is incredibly strong and easy to clean, and also I could even chop on there and I would not even mark it. Velvet cushions, obviously, for their ability to be soft, and the glass windows for their transparent ability. I was about to say translucent, sorry, transparent ability. That room has got a lot of natural light flooding into the room, and it makes it a very beautiful room. It's stunning views as well. Whereas this lampshade is translucent, and this comes back to the point I was making earlier. This type of light is a lot warmer and softer because of the translucence of the lampshade. So that is our work on materials and their properties, or the start of it. I would now highly recommend, as I said, that you go back and you pause and you make note of all of those different terms and their definitions. Now I'm going to say a big thank you for joining me. I have posted on to WorksheetCloud.com a nice little activity on materials and their properties for you to do, just to check your understanding of the work we have covered today. So have a lovely day further, and tomorrow you're going to have your lesson taken by a new teacher, one of my very close friends, and she's going to be introducing to you a new section of work on life and living. So enjoy grade 4, and I will see you again soon.